Alright, in this video I'm going to teach you how to kind of assemble your larger sequence from maybe smaller parts. Maybe you can't find all the exact parts, plus of course you have the problem of needing the intervening parts. Say if it's lac operon like here, you need that part between lac I and lac Z, and between lac Z and Y, and between Y and A, and then maybe some sequence after A also. So you need that those extra pieces, and I'm going to show you how to do that with Regulon, and then switching over to the NCBI to get the bigger picture. So we're going to find specific sequences here in Regulon DB because it's easy to do that. And so I'm going to type in lac I. Alright, so lac I to find the very first part of the lac operon. And right here it is, and I'm going to click, and it gives us this nice diagram, and here's where I find what I'm looking for. I'm actually looking for the position on the genome. And so here are some numbers that they give us right here, and I'm going to copy those numbers down. So I'm going to open up a text file, and I'm going to copy those numbers 366428. So 366428 and what is this? 367510. 367510. So this is our lac I. Okay, just think of it that way. Now what I also want to do is I would like to get some information about the region before it, and here is a gene that comes before the lac I. So I need to know where that ends, and I want to get everything in the middle before the lac I. So this one, the previous gene ends, let's see, this one begins at 366428, and this one 367. So I'm just going to put previous. I'll go ahead and get the whole thing. We're not going to want that. We really just want the end. But I'll go ahead and record that, those numbers, 367587. Make sure you type in the right one, 367. Now I've already forgotten it. 587. And that one goes to, now notice that it's going in the same direction, and that's good for us. 368420. 368420. Alright, so where is this? And this one ends at 367510. So what's going on here? We start at 366. Alright, we go to 3675. This one is 367587, and it goes to 368. So it is, this one is getting larger. Alright, this one is also getting larger, but what do the numbers tell us? This one ends at 368. This one begins at 366. There might be some overlap or something here, because these numbers 367, 368 to 368420. 368. So this gene includes part of this gene according to this, if I'm reading this correctly. So this gene, MPHR, starts at 367, but lac I starts at 366. Lac I goes to 367, and so they're kind of going down is what's happening. So 367510. In other words, the numbers are going this way, the genes are going the opposite. So it's a reduction in size. Oops. So that's why you have to realize kind of what's going on, and that's one reason I put it this way. So in other words, we should expect what? We should expect the lac Z to be smaller. Let's see if that's the case. I'm going to come back over here and I'm going to go to lag Z, 363, 363, 231. 363, 231. So 363, 231, 2. All right, 366, 305. 366, 305. 366, 305. Let's see if I got that right. 366, 305. Yes. So what is this telling us? Well, it's telling us that we're going the opposite direction. We start, in reality, this gene is going, if you want to think of it this way, this first one here that is not part of the lac operon goes from 368, 420 to 367. It's decreasing, heading towards 0. And really the lac I is at 367, 510, getting smaller to 366. Now your genes may not do this, may be going in the other direction. But realize that they're moving towards 0, not moving towards the end. They're moving towards the beginning. In other words, you've got the two strands and you have to keep track of what's going on, and we're on the strand that's getting smaller, if you want to think of it that way. All right, but at least we have some numbers here and we can start mapping this out more or less. So we have lac Z. All right, now how about lac Y? That's 361926. So let's map this out. Now you're going to have to do this for all of your genes. 361926. 361926. 361926. And that goes to 363179. 363179. 363179. Did I get that right? Yes. Okay, now we can go to what? To lac A. And lac A is 361249. 361249. I'll go ahead and write that. 361. Oh, I've already forgotten it. Let's see. 361249. 361249. All right. To 361860. All right. 361820. Let's check on it just to make sure. Oh, 860. That's why I go back every time. 860. All right. Make sure once again. 361249. 361860. All right. You do have to be careful. So this is lac A. All right, and then we want the gene after this because, look, now they're giving you some hints here. Look at this. What do you think this is? Those are what? They are terminators, and they're actually even telling you the type. So here are some hints that will help you if telling you what type of terminator you have. We've generally talked about the generic type, but now you know from looking at this what type the lac operon uses. You can use that on your in your paper to find yours. If you don't find a paper on it, you can find it from here, hopefully. If not, but here I want to get this one because we pretty sure that it's not going to move into this one, though that does occur. Occasionally you'll have genes overlap. This is indicating they do not. But you might have one gene running into a part of another one. It happens, going in the opposite direction. So this is 359992. So 359992. So let me write that down. 359992. All right, and that goes to 361146. 361146. So 361146. All right, and this is, and I'll just call it next. All right. So we need to kind of put these numbers together and find out the region from beginning to end that we want to grab. Now, some of your operons may not be grouped together, but you do need to grab all the way to the next gene in your operon if you can figure it out. If you can't figure out where the next gene is, you don't have something graphical like this to help you for your operon, you should. Regulon DB has most of this. It helps you out quite a bit. If you don't, though, I would go at least 200 base pair before and after your gene and grab all of that sequence. But let's see what range we need to get. Now, we don't want this range. We want the outer limits of this range, the one that's closest to one of these. So 368 or 367. Well, 367 is closer to these numbers than 368. So we know our limitation here is probably here. All right, now which of these is closer to our lac A number? So 3.5 is closer than 3.1, so we probably want this one. So in reality, we want all of the genome between 35992, or you could add 3 or 1 or whatever, to 367,587. All right, so we want all of this. Now your operon may be broken up into two parts that are far away. Lac I, which is a separate gene, just happens to be right before lac Z, Y, and A. Which is convenient, but your operon may not have its inducer or whatever they're calling and get their activator may not be right before your operon, so you may have to find it separately and do this for just that one gene, and then go find the rest of the operon elsewhere where they are grouped together. Now, you'll just have to, each individual operon you'll have to investigate. But we now have a range. Let's make sure that all our numbers are in between these two. So 3.5 is certainly before 3 6s. So so in other words, 359,000 all the way to 361, and 367 is 587 is larger than all of these. So yes, what we've done here is we have found the range we are looking for. So we are looking for a sequence along the genome of E. coli K12 from what? From 35992 all the way to 367,587. Okay, that's what we're looking for. And this would find supposedly the sequence that I already have. Like I said, the lac operon is well studied, so this sequence between these two is pretty much already it's well used, so it's already in the database. People have just said, oh, people are going to want this. Let's go ahead and put this out there as the lac operon, and they even included the I sequence. But actually, you really do want some more sequence out there. It would be nice to have it all the way to the previous gene and then all the way to the next gene. So this is probably the preferred way to do it than the way I did. They didn't do it. They didn't have maybe everything like the -35 sequence. I have a feeling from our previous, we're missing a few letters that could have helped identify the -5. So what we want is we want to get this. So how do we do that? Well, we go to the NCBI, right? And let's go back to the NCBI. I'm going to type in NCBI, but I want to go to gene. Okay, and home gene right here. And I'm going to put in this particular case, I'm going to put in, oh, I don't know, LAC-Z. Escherichia coli LAC-Z, and I'm going to look for K12 specifically. We need to find K12, beta-galactosidase, K12 right here. Alright, I'm going to go here. I'm going to go to this sequence, and we want to go to the FASTA. Make sure we've got it. Okay, and there we go. And it's telling us that it's from what? 363.231 and 363.305.1. Let's check and see if that's the same thing as ours. What did our LAC-Z? Our LAC-Z said 363.231 and 363.305. Great. Now, I am not certain that, and in my history from using these two databases, they usually are not the same. So you might have to make some adjustment there. And that's going to be difficult, and I can help you if you have to make some adjustments. You just got to move the numbers around and check. So you might have to go check the sequences and see where they line up. Hopefully they tell you the same like they did here. This is simply a well-used one, the LAC-Operon. So things are checked and updated regularly, but you may not have yours line up as easily as mine lined up here. So check that. So what, of course, we want to do is we want to put in these two numbers in place of these two numbers to get the whole sequence that we can do our analysis like you've seen me doing already. So you're going to need to do this, and to do that, let's see, so we are starting smaller to larger. This one is 363 to 366. Okay, this is also smaller to larger. So all we have to do is take out the numbers. We want to go from 35992, all right, to 367, all right, 587. All right, and we're going to update our view. Let me see, make sure I put those in, 367, 587, yes. All right, update the view, and now I have a complete sequence of the LAC-Operon, and I can grab that as a file, FASTA, and I will create that file. Okay, it is now in here as sequence. I'm going to change that name, save as, I'm going to call it custom LAC-Operon, and I'll put K12 in there too to let me know it's K12. Yeah, usually is. So let's put that on my desktop and save. Okay, so now we have this. Now I'm going to compare that, and you know, I probably ought to save this too, might need that. Locations, I'll just call it locations lac.txt, and I will save that also on the desktop. Alright, now, so what do we need to do next? Well, I am going to take that, let me find it here. What did we find? What did we call it? I have locations, and I saved it, custom LAC-Operon. I'm going to put it, I have a folder called LAC files. Alright, so I'm going to paste that here into custom LAC-Operon, and then I'm going to check this using dot plot, just to kind of give you an overview of the view of it. Alright, and we'll see how much mine compares to the others. So I'm going to open up Eugene, and it's going to take a second here, and I'm going to go Tools, Ask Later, there we go, Tools. I'm going to go down here to Build Dot Plot, and I'm going to grab in my file here, my folder in Desktop, I have something called LAC files, and my first one is going to be my custom LAC-Operon, and then my second one, alright, LAC files, is going to be just what I have labeled as lac operon, which is the standard one that they've created for you in NCBI that they probably have not done for your operons, but they have for the lac operon. All right, and we're going to look at them and see how much extra space I got on either end, and if they actually line up. If my old one was maybe a previous sequence and maybe it's changed a little, I don't know. So I assume the one I just got is up to date. The old one I got several years ago. I have not looked at it, so I don't know if maybe they've resequenced it or something. It shouldn't have. This is pretty stable, but I just want to check it just in case. All right, we're going to leave it at 100. We don't need inverted repeats. I just want to look at it, and I want to see if it's looks pretty standard. You don't know for sure unless you zoom in, but this thing looks like it's 100%. But and it looks exact. Let's see, this is 7,477, and this one is 7,596. So which one is longer? So mine, the one I grabbed, all right, is across here, and it's 7,477. The one they gave me, all right, the original is 7.5. So actually theirs is longer. And what this is telling me is I didn't actually grab enough. I should have grabbed into those previous genes. So in other words, the one I created is shorter than the one they gave me. And I don't see any major gaps in here. So what that is, they're telling me that there's an important sequence that actually feeds into the previous genes. So as a precaution, I would tell you that we might have done this incorrectly. Maybe the correct thing to do would be to actually grab those two genes on either side just to make for sure. So in other words, when I went and found this, oh, actually there is a break. Hold on. There is a tiny break in here. Oh, let's check this out. So there is a difference between my sequence and theirs. So this is kind of interesting. I didn't expect one, but there is a tiny difference between the two sequences. Now, how many base pairs is that? Will that account for our difference? 64. Is that the difference between these two? So 64, let's add that up. Maybe this is where the difference comes. So I have 7,477 plus 64. That would make, no, still doesn't make up enough. There might be more than one break. So that is interesting that that we actually have. Oh, and here it looks like there might be another break. Oh, there's some overlap. Interesting. Well, it means that my old one and the new one are not quite the same, and I would use the newer one, the one I found at the NCBI here, but I would go a little bit into the two outer genes, maybe grab all of them. That seems extreme, but you might go 100 or 200 base pair. It looks like probably if you were doing it this way, 100 into the previous gene, or into the next gene, and on either side, just to do it. So if I were to do this again and we were on the NCBI, I would have 100 maybe base pairs on either side, just to make for sure that you got everything. All right, now let's take this and let's do another dot plot, and let's just confirm that everything is where it should be. And by that, what I mean is, let's do another dot plot, and we're going to use our custom K12, and we're going to compare it to lac-I. Now, where do we expect to be? Just to make sure we find the lac-I where we think it should be. And yes, we found it up at the beginning. So here's where lac-I is. Lac-I is over here. And in here, ZYA are going to be here. All right, so that's great. Now, one thing you could do is you could combine I, Z, Y, and A into one sequence. Just make them one after another and make it one FASTA. And then what you would get, it would look like splicing. And the pieces in between would be your regulatory region. So that would be a way to view the entire LAC operon. So why don't we do that? I think that would be an interesting thing to do. So let's try that real quick. I have this available, so why don't we do it? Let's create a new document. All right, and I'm just going to call this thing LAC parts .FASTA. All right, and then I'm going to take LAC parts. Where is it? Right here. I'll open that. And what I'm going to do is I'm going to start with LAC I, open reading frame, and I'll just grab the whole thing since it's the beginning. I'm going to grab this. I'm going to go copy. All right, and I'm going to go, oh, that's not what I want. LAC parts, and I'm going to do this. I'm going to change this, of course. We'll just call it LAC parts. I, Z, Y, A. Okay. And we're going to grab the others. So I have I. Let's grab Z. So I'm going to take the first part. I'm going to grab that. I'm going to go copy. We're going to go back to LAC parts. And you are allowed to leave spaces in there. The programs will read it usually. Depends on how old, and most of them have figured this out over the years. Just don't put the greater than sign in between them, and you'll get it'll read them correctly. So I can put this in here. All right, and then I need what? A. Like A is small. All right, now, so I have essentially I, Z, Y, and A all in one piece. I'm going to save that. Actually, I already have it saved as that. We'll replace. Okay, so now let's go do a dot plot with all of these. So we'll open Eugene, or already got Eugene open. All right, we will go to Tools, Build Dot Plot, and we're going to grab our custom operon here that we've made, and then I'm going to grab, where is it, LAC parts, and hopefully we'll see something very similar to splicing. And yes, we do. So what we see here is here's LAC A, and then here's the region in between them, and here's LAC Z and the region between it, and LAC Y, the region between Z and Y and A. And so you can click on this maybe, and you see the region. Let's see if we can zoom in down here, which would be better, I guess, zooming in up here. So we want the regions in between about here and here. You get on it, come on. Let me click on it, it won't let me click. Oh, that's because we're down here. Ah, okay, now we're back. All right. So here is our beginning part, and we're going to scroll toward this area, and that is at 1160, and then we're going to grab this, and that is 1283. So the difference between 1160, all right, and there, that would let you find your numbers in between these two regions. That's just one way you could do it to look at it graphically here. That's not the way I would prefer, but you can go grab these pieces, all right, in between here, and you could even go and search on the on NCBI and just grab those separately. But I would grab them, and I would grab a little bit more on each side, just a little of the others, keeping in mind where they are. So I would probably grab, and I would grab that, and grab this piece right here, all right, and then compare it to what you've already done, just to make sure you know where everything is, know where this one starts and this one ends, and then kind of work on it there. Then you would do it here, find where one begins and one ends, and work on it there. Kind of what we've already done in previous videos where we were looking at everything. But you can check everything with dot plot. Dot plot lets you check everything to make sure everything is where you think it should be. So this is just some things you can do to assemble a sequence that you can work with, like I showed you, and use it in my program. Mine is really good at looking at everything as a whole and then finding the locations and the pieces and things. But you're going to need to assemble that long one, all right, before you can go forward. And this is a method for you assembling it. There are other ways to assemble it. You know, you can figure out whatever you have available and try it. But this is what I would recommend.